Skyler, welcome to the podcast.
Howdy, thanks for having me.
So I'm excited to have a geologist on the podcast because I've probably listened to hundreds of hours of climbing podcasts, and I don't think I've ever heard one where somebody talks to someone who actually knows the most about the people who study the rocks that we climb on. So it's good to have you here as an expert. I appreciate you being here.
Yeah, thanks. I'm psyched to be here. I walk that line between geologist and climber, and it kind of like enhances my enjoyment being both. I kind of get to step in both worlds and enjoy the aspects of climbing because I see the geologic value and where I'm going, and enjoy geology because I think about the climbing while I'm thinking about the rocks. It's pretty cool.
Nice. Yeah, they pair well together. Can you just tell us who you are and where you're at and all the general stuff?
Totally. So I'm in Flagstaff, Arizona. My day job, I work for the U.S. Geological Survey. I got a PhD in geology in 2021, and I'm wrapping up a postdoc here in Flagstaff. I've worked for a number of different state geologic surveys. So I worked for Colorado. I worked for Washington for a couple of years. I've done geologic research in a whole bunch of places, like different states, places across the West. I work out in the desert right now in southeastern California, but I did my dissertation work in northern Chile. I've done field geology in northeastern Mexico. So a bunch of like geologic settings. The geology I do research. I do tectonics research and structural geology. So what that means is that I look at deformed rocks and try to understand, what deformed them and how does that relate to plate tectonics? What happened and when did it happen and how did rocks get squished and faulted and folded? And one of the tools I use for doing that is geologic mapping. So we go out and make maps of the geology and, show where different rocks are. And that's gotten me a lot of field time, which is really cool.
Awesome. Which came first? Have you been climbing longer than you've been interested in or studying geology?
Climbing first. Yeah. So I've been climbing a long time, since like the end of the 90s. So okay. I'm probably on like the front end of the birthday party generation. So I went to somebody's birthday party when I was in like third grade at the climbing gym, and I got really excited about it. And then, they had an after school program, and this was like a grungy, like warehouse climbing gym in Montana. Very much like a 1990s climbing gym.
Yeah, there weren't that many climbing gyms in the late 90s.
No, it was cool. It was like people we knew in a relatively small town. It was like, kind of core climbers that had this gym. It was honestly like a passion project of someone who lived in the town. So that was cool. And then after doing like the after school program for a year or two, my parents would come in and belay me, and after a while they're like, hey, wait a second, we like learned how to do all this rope work, like we should buy some of the gear and just start going out as a family. So then we started like doing like cragging family days, on a Saturday or something. So kind of for years I was like a really casual climber, pretty young, but just like slowly got into it. And then as time went on, I started going out more and more. It's really been like the last 5 years I've gone climbing a lot. For a really long time, I was like, oh, I'll just go when it's convenient and my friends want to. But I've gotten like more and more psyched on climbing as time's gone on, which is pretty fun.
Yeah, that's cool. That's a cool story. I mean, obviously, I'm about to be a parent. I'm not yet, but I'm really grateful. One thing I'm grateful to my parents for is that they gave me an appreciation for the outdoors, like from a very young age, which I was super resistant to at the time, but now I really appreciate that they did that for me. And it seems like growing up in Montana and going climbing with your parents probably had to have done something to like spur your appreciation for rocks in general.
Totally. Yeah. So as far as the geology side of things, I took a class when I was out from college. I didn't know what I wanted to major in. I just kind of took geology as like a science credit and was like, wait a second, this is super cool. And I started talking to people. I had made friends. I was kind of into kayaking, and I made friends through kayaking with a guy who was a geology grad student. And I was talking to him of like, what should I major in? And he had gotten a degree in geology, was getting a master's degree, and he's like, if you can tolerate the science, you should do this. It's super cool. And something he told me But I totally blew off at the time. He's like, geology will change the way you look at the world. And I was like, yeah, whatever. And now looking back on it, like many years later, it's like, wow, he was totally right.
That's
uh,
cool.
yeah.
Yeah, so they've been pretty intertwined for quite a long time then. 'Cause I guess you give me the timeline here. You took a class in college, but then you got your master's not that long ago. And I think we're pretty similar ages, so there must be some intervening years there.
So I graduated with a geology degree from Bellingham, Washington, Western Washington University in 2012. And then I kind of thought I was going to go right off to grad school, and I was like, I'll take a gap year, and it ended up being 5 years, and I don't regret that at all. It was awesome. So I
Gotcha.
had a pretty good chunk of time in between, and then I started grad school at Colorado State in Fort Collins, initially to get a master's, but I ended up getting a PhD. My advisor
Gotcha.
talked me into it. I was kind of resistant at first, and then he was persistent, and he talked me into it, and it turned out to be a really good decision.
Well, it doesn't sound so bad traveling to Chile and New Mexico and all those places
No,
that you
it's
listed. That
not so
sounds pretty
bad.
fun.
Writing up the papers is maybe less glamorous. You know, there's kind of a day job side to geology, and you get a ton of screen time and everything. So, but no, it's the field work is really fun, and the science behind it is like I find it really motivating. I'm interested in the stuff we're doing, so that makes it a lot easier.
Yeah. Yeah. I mean, it really does. I mean, that's part of why I wanted to have you on the podcast because it is called Inner Fire. And like from the first moment we were talking about it, I was like, oh, this guy lives for this. Like he's super passionate about rocks. So, yeah. So I'm excited. I mean, today I want to talk about a few different things. I think it would be cool to just go into some of your climbing just to establish, kind of, who you are in the climbing world and what kind of climbing you're interested in and stuff. Talk about rocks and what makes rocks good for climbing and different types of rocks, which I know we could probably do a very long lecture on that. And personally, I just, I'm interested in performance. So I'm curious about the, what can we learn about the rocks and how can we engage with the rock that will improve our climbing, that kind of stuff. So hopefully we can sort of cover a little bit of all that. I'm sure we'll deviate into other random interesting stories and stuff like that. So
Yeah.
let's start with you. I think, let me see. We worked together. I coached you for, I can't remember if it was how short it was, but it was just a brief thing. I think in 2023, maybe something like that. I think you were just getting into training. And at the time,
Yes.
I want to say you were working on projecting, you were really interested in big multi pitches. Do I have that right? Am I remembering that
Yeah,
right?
yeah, that sounds right. I had some sport climbing goals and some multi-pitch goals. We kind of have both where I live in Flagstaff, which is pretty cool. There's
Mm-hmm.
sort of different seasons for these things, or the seasons sort of overlap too.
Mm-hmm.
Yeah, and I had it. Yeah, you wrote me a training plan. We did a consult and everything. And it was great because I was so new to that idea. I had never lifted weights before. I'd never done a deadlift before. I'd just started that right before I reached out to you. And, how do I work that into my training plan and that kind of thing? I didn't really understand finger training. Not that I do at this point anyway, but um,
Well, there's a lot to understand.
totally, yeah. So yeah, and then the climbing around here. So I live in Flagstaff. I've been here 5 or 6 years or something. We have 4 different rock types to climb on. There's limestone sport climbing. We've got dayside sport climbing. We've got sandstone, which has sport and trad, and it's got multi-pitch on it. So folks have probably heard of Sedona. It's got really fun stuff. Sedona's got kind of an old school, tower summit, desert tower vibe, but it's also got these newer climbs that are more on faces higher up that are really high quality, that are pretty fun to come climb. So I've gotten psyched on stuff like that, and yeah, climbing quite a bit.
I have only very briefly been to Flagstaff. I didn't actually get to climb there because I had been injured in Tucson and I was on my way, or I wasn't on my way home, but I think I just walked around and then decided to give up and go home. But I was shocked because the few places that I went and looked at all had vastly different rock types within a pretty small. I mean, I'm more a boulderer, I think, than anything. I'm trying not to pigeonhole myself too much these days, but obviously I was really curious about Priest Draw and the wildly overhanging roofs that they have around there, but also I think there's some basalt crags and some sandstone crags. Is that related to the fact that you're doing your geology, finishing your studies in that place?
I mean, yeah, choosing where I wanted to do a postdoc, definitely considering like outdoor access mattered. It
Yeah.
didn't have to be Flagstaff, but I think a lot of people can probably relate to wanting to live in a good place that has good access, convenient climbing.
I guess I meant like, was it chosen because it's also geologically interesting in addition to having good access to climbing?
Yeah, although the funny thing is, my research actually isn't in Flagstaff. I drive like 4 or 5 hours out into the desert. There's there's a USGS office here that I work in, but our research project is kind of further away. Although some of our research is in the Grand Canyon, and Flagstaff is kind of as close as you can get, even though it's still not super convenient to get into Grand Canyon. There's a lot of places we want to go that it's like, oh, it'd be hard to get to.
Yeah. I feel this like magnetic pull to start talking about specific like rock features. Like I so badly want to talk about Priest Draw, which wasn't even something
Sure.
that was in the outline that we
Well, we
had.
can talk
So
about it.
I'm gonna
Yeah.
I'm gonna pull back. I'm gonna pull back from that for now. I wanna ask because you said that you were a casual climber for a really long time, and then maybe like 5 years ago you just got really fired up and kind of started taking it more seriously. Like what made you make that change?
That's a good question. I'm sort of an opportunist in like recreation, in the sense that like whatever's really easy and convenient, I'll go do on the weekend. For a long time, that was like skiing or kayaking and climbing, or maybe like a little bit of mountain biking here and there. I've lived like growing up in Montana. I was really close to a ski area, and I went there a ton and got super psyched on that. Living where I live now, the climbing is really convenient, and I also kind of like fell in with a friend group that's pretty psyched on it. So it's sort of like I have all these friends, and I call them up, and everyone's going climbing on the weekend, and that's kind of the activity. So I think that probably
Gotcha.
motivated a lot of that. If I lived somewhere that was like right next to a ski area or like right next to a good river for kayaking, I would do that on the weekends too. Um, so it's, you know,
Podcast over. We're rock climbing chauvinists here.
just yeah, right. Yeah, I'm kicked out. Not allowed.
No, I mean, I think that's interesting because you're also climbing like at a pretty high level for somebody who would, do other sports happily if they were at hand. So, yeah.
I was talking about this with someone recently, and I realized we were just talking about like our progression of climbing, and I was like, yeah, I probably climbed for like 15 years before I did a 512. And then I thought it through, and it was exactly 15 years since I started. As a kid, I was just kind of dinking around in the gym and stuff and climbing like 15
Hmm.
days a year. But
Hmm.
it really was like a very slow burn before I like finally did a 512 sport climb. And even then I wasn't really projecting stuff. It kind of like took some more time to be like, hey, if I do this more, I get better at it, and it's even more fun.
Yeah, it didn't get your hooks in you the way that it does with some people, like quite as fast, but probably just because you were getting good at lots of different things at the time.
Yeah, I did a lot of like 510 trad climbing. So a lot of like I'd go out with my friends and we'd try to do like a longer route or something, or like we were pushing into those grades, and that was kind of like a slow advancement. You're not really doing a whole lot of hard moves, so maybe not getting a
Yeah.
whole lot better. And we were not intentional about our climbing back then. It was just like a thing we did.
It builds a base because I think you just develop skills very differently when you're in those younger ages than you do when you're older. And like, I actually don't think I've talked about this on the podcast. I don't think it's embarrassing, but it's just weird. Like I didn't learn how to ride a bike until I was like 23 or something like that. Like I just walked everywhere when I was a kid. I was way more interested in like computers and PlayStation, and so I never learned how to ride one. And so later I learned in my 20s, and like I can ride a bike. I can get from point A to point B, but like Black Diamond trails on a mountain bike like are out of the question for me because I don't have the confidence, that you develop when you learn how to do it when you're well, now kids are learning how to do it when they're like 3 years old because they have those little bikes with no pedals. But yeah, when I was a kid, it was like 6 or 8 or something. So I could see starting climbing at that same age would be really formative for your climbing skills for sure.
Yeah, I think so. Even though I didn't do it that much, I think it mattered a lot.
Yeah. Yeah, that's cool. So can I ask like maybe what some of your favorite climbing experiences have been since you started taking it really seriously?
Oh, sure. Good question. I've climbed some routes that I never thought would be in my wheelhouse. Like, so for instance, there's this route in Sedona that's got a pitch of 12 plus, and that it's like it's kind of labeled in one of the guidebooks as like this is the only route that gets 4 out of 4 stars. It's like kind of the big one, and I was like, wow, that'd be really cool to do like in 5 years or something. And I just kind of like climbing more and more, climbing with people who were, edging on that level. Someone was like, hey, we should just go try it, and getting on a route like that. And like, I didn't do it the first time, but I did do it the second time. And it just like, that was totally mind opening in the sense that like, I did not think that I would ever climb that grade on a multi pitch or something. So that kind of thing's been really rewarding. And it just like
Cool.
opened up, not that climb specifically, but just like being able to get on harder climbs. I definitely remember like climbing in the Cascades when I was in college and being like, oh man, if only we felt solid on 510. There's so many
Mm.
climbs we could do. And it's like I look back now and it's like, wow, I have come a long way. So I've been reflecting on that, and like that feels really gratifying. It's nice to show up to a crag and you're like, I can get on a lot of the stuff. I'm not just limited to the easy climbs, you know.
Totally. I mean, I think that's the most honest argument for wanting to progress is just, you just don't want to feel limited when you go to new places, right? But the funny thing about that is it's, in my opinion, that's more about raising your floor than it is about raising your ceiling. But everybody focuses on progression as being about raising their ceiling. But that's neither here nor there. Was the thing you climbed in Sedona sandstone?
Sandstone, yep. Yeah.
Yeah, I guess a lot of the big like towers and walls there are probably sandstone, huh?
And there's higher up sandstone and lower down sandstone. A lot of the towers are on the lower down stuff, the Schnebly Hill Formation, which is chossier. The higher up stuff on Coconino sandstone is a little bit better. So that tends to be where like the better climbing quality is, but it's not like the scenic, iconic summits or something.
Okay, so the naming of the sandstone layers, this is something I've heard with like Dakota sandstone and Aztec sandstone and these sort of these different, I can't tell if these are monikers or what is that when we're naming the sandstone?
Yeah, so they're formation names. So there's actually like a very strict stratigraphic nomenclature. Stratigraphic, that's like sedimentary layers, like layering of rocks, and then we group them into different age and lithology categories. And there's like a very strict code. It's like a stratigraphic code that we use to define. There's formations, there's members that are subgroups of formations. There's groups and supergroups that are bigger categories that include multiple formations, and there's kind of like a strict set of rules. If you want to name something the Dakota sandstone, you have to define like where it's located, what it looks like. So yeah, all that to say, there's like it's actually like a very kind of carefully controlled nomenclature system that geologists use, and it does change over time. Where like people name something one thing, and then somebody else comes in, and they're like, actually, I think this is two different layers of differently aged rocks. We got to change this naming system. So when you look at old papers, they might use like outdated terminology, and you're trying to figure out like, wait, did this old paper use what we use now, or did they use something different? How did the terminology change over time? So yeah, that's kind of the system.
Yeah, so it's like a mix of like the way that we name lakes and rivers and mountains and things, but also like there's a little bit of like science because I assume people are
Yep.
submitting white papers or something on these different layers.
Yeah, I mean, you put it in like a scientific publication. There's kind of like a formal way to define these things. Yeah, and there's a whole bunch of work that goes into the paleontology, and you have to figure out how old things are. It gets really technical.
Yeah. So you kind of mentioned that the lower down layers were chossier, and with sandstone in particular, I don't think we need to go in any specific order because this isn't like a geology class necessarily. But with sandstone in particular, it seems like I've heard that it has something to do with like how much of the sandstone is made up of is like quartzite. That has something to do with how chossy it seems. Is that accurate or is that wrong?
That's probably not the best way to put it. You could think of so sandstones. The sand itself can have different components. So
Hmm.
a lot of the sand we climb on, it's dominantly quartz sand. So the sand grains are just individual quartz grains. You can have other stuff. So you can have like lithic sand. So that would be like chunks of other rock. Like maybe you've got teeny tiny sand-sized chunks of basalt and I don't know, chunks of metamorphic rocks, and those get turned into sand, and then that gets turned into a rock. So that's the sand itself. But then what also matters is the cement that holds it together. So in between all these grains of sand, there's minerals that have precipitated that keep everything stuck together. And kind of like the more you precipitate, the less pore space there is, the higher density there is. And then also rocks get compacted and the density increases and the porosity decreases. They become harder, stiffer, better rocks. So it really kind of
Okay.
depends on all those variables. A lot of the sand we climb on is quartz sand though. So I'm thinking of like Indian Creek or Las Vegas or Sedona. It's almost entirely quartz sand. Um, yeah, and quartzite is a metamorphic sandstone. That's a metamorphic rock. Yeah, yeah.
It's not the same. Okay, all right. I want to press pause on that because I have to say, when you sent me your geology for rock climbers little outline that you sent me for this podcast, which is amazing, and I learned because I'm just a geology noob that sandstone is actually just made up of sand and some kind of like the thing cohering it together, like cement, I think. I was kind of, I'm not a huge sandstone fan, but I was kind of mildly horrified. I was like, oh, that's why sometimes when I'm climbing on sandstone, it feels like it's going to explode in my hand.
Yeah. I mean, if you can see if you get like geologists use a hand lens, or if you were to cut it up and look in a microscope, it's just little grains stuck together. Even if you just pick up a rock and kind of hold it close enough, and then the coarseness of the sand can change. So there's fine sandstones where the sand grains are pretty small. There's coarse
Mm-hmm.
sandstones where they're bigger. If they get coarser than that, then it starts becoming a conglomerate. So that's like where you have clasts, like big chunks of gravel making a rock. It's essentially the same thing as a sandstone, except that it's way bigger. The chunks of the clasts are more macro, and the same thing in. Oh, go ahead.
Maple Canyon type place.
Yes, yeah, that's probably like a famous quartzite climbing example. Sorry, a famous conglomerate climbing example. Um,
Yeah, I mean, on the like fine grained sand texture thing. So I've climbed a decent number of places around the West. Some of the more notable sandstones I think that are really popular, and I've also climbed on some really crappy sandstone in places like, well, maybe you climbed at like Elwha when you lived in Bellingham. You may have been to some of those places. I think that's like it's on the peninsula. But it's very sandy. When you grab holds, you feel like you're pulling sand off of them. And then I've climbed in places like Fontainebleau where it is sandstone, but maybe it's actually not sandstone because there was no sand. It feels the same, but I'm not pulling bits of sand off the hold. So maybe that is just quartzite. Maybe it's actually metamorphic.
I looked into that because you're interested about Font. I have never been there, but I looked to
Mm-hmm.
see what I could find out because you're asking about it specifically. That there's really cool rock, and that one's a really interesting case. So it's a sandstone, and there's layers of really hard, very well cemented sandstone in with layers of, it sounds like, hardly even rock, unconsolidated sand.
Hmm.
And really what that has to do with is like cementation, silicification. So there's quartz sand and then there's a quartz cement that's filled in all the spaces, and it's filled in so much that it's just like the rock is almost entirely quartz. And it sounds like with the Font sandstone, it's very pure quartz sand. And there's actually a term. This gets really confusing. So you can call it a quartzite. Technically, it's
Okay.
an orthoquartzite, as opposed to a normal quartzites. Metaquartzites are metamorphic rocks, and you get
Okay.
those when you take a sandstone and bury it deep into the crust, and under a whole bunch of temperature and pressure, it metamorphoses. The grains recrystallize, and then they kind of stick together better, and it becomes a whole lot more dense and strong.
Okay. So that's kind of the formation process that it went through in order to seem less like it's going to explode under my hands when I grab it.
Yeah, and that's it. It kind of highlights that there's so many differences in rocks. So with the Font sandstone, my understanding is that it didn't get buried very deeply. It was never buried more than like 100 meters or so, which is not very much. A lot of the
Mm-hmm.
sandstones in the western U.S. were buried kilometers or more, and they can still be soft sandstones. But because of that cement, that kind of made it good rock. So there's maybe
Yeah.
the relevant point here being that like a sandstone is not a sandstone is not a sandstone, in the sense that there can be so much variety within one rock type, depending on a ton
Yeah.
of different variables, like the cement or its burial history or what exactly the sand is made of, the different sizes of things, and how well they fit together. So there's a ton of variables.
Like having spent so much time bouldering, I tend to notice, like I try to notice the big picture of what's happening when I'm in a climbing area. And like most of the time when you're bouldering, you're going to be below some other feature that exfoliated these huge chunks of rock that you're now climbing on, like in some way, or it's going to be a glacier like dropped and it's like kind of erratic. But there's usually like some sort of logic to how the boulder got there. And the thing that I found really bizarre about Font is like it is literally just a sandbox. Like you're just walking around in the forest, the ground is sand, and there's just huge crazy boulders. But it's like pretty flat. The tallest hill that we climbed the whole time we were in Font was like 200 feet of elevation or something like that. There's really nothing going on in the topographic like nature of the area. It's really bizarre.
It That sounds super interesting. It really makes me want to go to Font, which I already want to go to.
Yo, you definitely should. I mean, as a geologist and a climber, like you have to for sure.
It sounds super interesting. Yeah, it sounds like there's these lenses of like silicified sand, and then underneath that or above that in other places, there's the rock is not as silicified, and like you said, it sounds like the forest is otherwise pretty sandy and like not even really rock. So
Yeah, it feels like a beach, except for you're not anywhere near any bodies of water, really.
that's so interesting. It sounds like a nice setting for bouldering.
It's really strange. Yeah, nothing else quite like it that I've seen. You said silicified, I think, a couple times, and dare I ask what that means?
So right, so silica is one of the main components of rocks in the crust. Um, so, like quartz, for instance, is silica oxides, SiO2, and that's like a major, rock-forming mineral. A whole bunch of other minerals you've probably heard of, like feldspar, and just most other minerals that you can think of have silica in them. Unless they're things like carbonates that wouldn't have any silica, or actually there's loads of other minerals that don't have it, but many of the rock forming minerals have silica. But you can also get silica in cement, so getting like quartz cements, we would say that something got silicified if a whole bunch of fluid came through and it deposited all this quartz or silica rich minerals in something, filling in those pore spaces. I'd call that silicified. And that can really change the quality of a rock.
Right. Yeah, that's kind of what it seems like. So, I mean, I'll hold off on getting into the resources that you showed me before, because I think those will be interesting to go through a little bit at the end. But what I'm taking away from this is that like there is a geologic history to the sandstone, and like understanding that history is going to pretty directly tell you something about like how it's going to feel to climb on those rocks, and maybe even like how safe it is to climb on those rocks.
Can do, yeah. It's funny. Like being a geologist, there's certain things that I can kind of gain an appreciation of, the science and the genesis of these rocks. Like how did they come to be where they are? And there's degrees of, as a climber, I don't always like, my geology background doesn't always help determine what it's going to feel like, or if it's chossy or not. You can kind of predict like broad scale patterns. But like, is an individual hold going to break, or like, what's this one going to feel like? You may or may not know. You really do get used to kind of like finding, yeah, you really get used to finding like the nuances in rocks, and you can kind of pick out some geologic patterns of like certain hold types might have a certain feel, and you're like, oh, that's because, they're this type of edge. They're like, maybe there's like an iron oxide little edge that you keep seeing over and over. So there's definitely a geologic component to that kind of thing.
Yeah, but like when you're actually on a multi-pitch doing the 510 bit that you've like never done before, like you're probably more like pull down, not out, like the rest of climbers, I assume, and not so much like making assumptions based on like what you read in some geology paper.
Right. You do get a little bit of a sense. I mean, I think climbers get so much experience working with rock that you really get like the relevant experience just being on the rock. But you can get a sense of a geologist. We look at a lot of rocks that are not good for climbing, and so you get pretty in tune with what those things look like. And so you might see it when you're on a climb, like if the rock changes color really suddenly, if it goes from being like red to super white, or if it's like greenish or something. It might be altered, like the minerals may have changed in some sort of fluid rock reaction, and that might turn
Hmm.
into bad rocks. There's kind of some patterns you can tease out that way.
Yeah, that makes sense. I mean, I think there's probably some parallel to like language there, where you can speak a language without necessarily being able to write it or even understanding like the exact grammar. Like you can get by, and there's probably something similar to that, because I feel like one of the most interesting things to me, having spent you know the majority of my climbing life on granite and basalt, when I go climb on different rocks, especially I think limestone would be the one that I've been the least exposed to. I just am so bad at predicting how things are going to be shaped. Like when I'm climbing on granite, like I'm on some new thing I've never been on before. I do some blind reach around a corner and I just always grab like the right part of the hold. Like my body just understands something about how it's shaped. And as soon as I'm climbing on limestone, like I don't have that anymore. I don't speak that language as much. You know what I mean?
Yeah, totally, totally. It's yeah, I mean there like on limestone there might be feet everywhere. There's an interesting word that so like limestone texture. Have you ever felt limestone that gets really pointy, like especially if there's like a flat surface of limestone and there's all these like kind of spikes sticking out? There's a word for that called Rillenstein, which apparently I don't speak German, but apparently means rilled stone in German. And that kind of texture can lead to like having all sorts of like little micro feet everywhere, or like just little features, maybe like teeny little holds that you can get a couple fingers on, but not your whole hand or something. Or if you need like an intermediate foot, there might be some little spike, that kind of thing, especially on like slabby limestone where it's and then that process is from like where it's being dissolved from rain or water coming down. It kind of like dissolves and reprecipitates and makes this sort of spiky texture to it. Um, so that can be a kind of thing to get used to.
I feel like the limestone, I mean, I just haven't had that much experience with it, but it is simultaneously like the sharpest and the most polished rock that I've climbed on. I know exactly what you're talking about with the little, it's almost like like a, I don't know, spiky, like
Yeah,
insect shell or something when you're grabbing it. Yeah.
Crosley, or some people call it like rip pants texture. Like if you sit down on a rock like that, it's gonna like rip a hole in your pants when you stand up. So,
Yeah. And that's different than chert, which I think I've climbed on a little bit also on some routes in the Utah hills that's like the black stuff, I think.
yeah, darker stuff. It can be a bunch of different colors. So
Okay.
chert is actually microcrystalline silica. And where a
Okay.
lot of climbers encounter it is it can be in with limestone. So it's
Right.
interbedded, interlayered with limestone. And there's a couple different types of chert, and that one's called nodular chert. So I'm not an expert on this, but my understanding is that like limestone is a marine rock. This is something that like formed at the bottom of the ocean. You have like mud, and a lot of what it is shells and hard parts of critters in the water column that kind of rain out and makes this mud. And my understanding with chert is you have a lot of calcium carbonate shells and parts that turn into the limestone, which is calcium carbonate. But then you also have silicious, so like quartzose hard parts of these creatures. And then during what's called diagenesis, when you take mud and it gets buried, diagenesis is when that's lithified, turned into a rock. Just kind of like
Hmm.
things heat up a little bit and it goes from being unconsolidated to consolidated of a rock. There's actually some sort of chemical reaction that I don't understand where those things kind of segregate. Imagine like oil and water a little bit. All the silica kind of clumps together and all the carbonate clumps together, and so you get these nodules of chert. But the cool thing for climbers is those. So because it's silica and it's quartz, it's harder and it's more resistant to chemical weathering. So on the scale of hardness from 1 to 10, calcite, which limestone is made up of, that's a 3, and quartz, which chert is made up of, that's a 7. So they're quite different in the level of hardness. Plus, calcite's more susceptible to chemical erosion. It can kind of dissolve in acid rain. So what ends up happening is oftentimes the chert will stick out. So you'll have like limestone's the gray rock, and then there's this darker kind of stuff sticking out, or those parts that stick out. Sometimes they fall out and they leave like vacancies behind them. But those often make the holds that you're grabbing. So you'll see like it's maybe mostly limestone with bits of chert in it, and maybe those bits of chert are what you're grabbing on some limestones. But then other limestones don't have this at all.
Yeah, and it's interesting that the chert is much harder. I guess that when I remember grabbing it, that does make sense. But I also feel like it has like a notoriety for being chossy. So is that just because what I'm grabbing is really hard, but it's not particularly well adhered?
Yeah, the unfortunate thing is hardness does not totally correlate with chossiness. It'd be better if harder rocks just meant better rocks, but that isn't always true. And a lot of that has to do with like when things are fractured. I mean, think of basalt. Basalt is a really hard rock, and there's really good basalt to climb on, but there's also basalt that is totally choss. Stuff that's just like fractured every which way, and you just don't want to climb on it. It's terrifying. Stuff's gonna fall out. So yeah, probably the same thing with chert is it kind of depends on the fracturing and because they're in these nodules, they're not like big, thick, homogeneous layers. They're kind of smaller pieces that might be more prone to falling out when you yard on them.
Right. Yeah, I love that you brought up basalt because as someone who started climbing in Oregon, and I've done a lot of climbing in Oregon, like not a state that's notorious for its rock quality, but definitely a state that's notorious for its climbing history. So it's interesting that those things can coexist. But actually, like, while Smith Rock, which is what Oregon's most well known for, in my opinion, is like nothing really to write home about in terms of the rock. It's like really beautiful, but once you're actually climbing on it, it's really not like, I don't want to like hurt anybody's feelings because people might love Smith Rock on this podcast. I'm not personally the biggest fan of climbing on tuff. I feel like I'm going to break the holds off, and when I fall, I'm going to pull the bolt out too. And that doesn't actually happen that much. It's just a feeling that I get there. But the basalt in Oregon, a lot of it is really quite good. Just it's so compact, and it doesn't tend to form a ton of holds. But when it does, there'll be like really bomber edges or like really interesting slopers and stuff. And I feel like basalt it just doesn't really have much of a reputation at all. But if it does have one, it's probably for the like more fractured, like columnar type basalt. And those are like some of the most interesting rock features that I've ever seen. Places like Trout Creek, and the gorges at Smith Rock, where it just has this clear, open book, arete, open book, arete, like sort of pattern to it. Like, okay, what is that? What's happening there?
Yeah, so that's columnar joining. So you like the columns that people talk about. They form hexagonal or yep, yeah, that's another one. A lot of the climbing here in Arizona is that way. We have basalt flows that have columnar joining. So really what that is a cooling feature. So basalt like that is these lava flows that flow out across the landscape, and different rock types, different volcanic rock types, depending on their silica content, will have different viscosities. Basalt is relatively low viscosity, relatively low silica. So the opposite end of the spectrum would be like a rhyolite that's a volcanic rock that also erupts, but it has much higher silica and it's a whole lot more sticky. So the eruptions tend, instead of like these flowing lava flows, you tend to have like explosive eruptions with something like a rhyolite. And then dacite would be in the middle of that, of kind of dacite and andesite. Those are like intermediate compositions between basalt and rhyolite. So the basalt flows and they flow out. Imagine like Hawaii is a really famous example of basaltic lava, where you have like you can have like kind of rivers of lava and it flows out across the landscape. And yeah, like Oregon, Washington, where I am in Arizona, we have a lot of basalt. You have these lava flows that kind of like create a pretty flat surface and are just flowing out across, but they can be really thick. They can be hundreds of meters or something thick. And that's a whole bunch of hot magma that then cools and solidifies, and that's kind of a long process. As it's like cooling, it takes a long time, and the rock is kind of solidifying. And as part of the cooling, I don't quite understand the physics behind this, but it'll contract and it breaks these columns in that kind of classic columnar jointing. You get these fractures that form perpendicular to the cooling surface. So they'll form, often kind of straight up and down because it's flowing out across a flat landscape or something. And they contract, and I think it's just kind of like an efficient way to shed the heat as they contract into these, eight-sided or six-sided, whatever they are, columns. And that makes like the famous trad climbing areas like Trout Creek and that kind of place where you have like, you know, cracks in between, and then maybe you have like stem boxes or arêtes in between them or something.
Yeah, at the gorge in Smith, they always call them innies and outies, which I think is just like a really endearing term.
Totally, totally, exactly. Yeah, those make really fun climbing. But then basalt also, so higher up or lower down, it cools differently. So you can have different parts of the lava flow. So we talk about like colonnade and entablature. Those are different parts of a lava flow. And you've probably, if you've ever been to basalt sport climbing areas, you can see places that they're still parts of lava flows. They have kind of the same geologic history, but they have a totally different feel to them. They don't have these ginormous columns. They'll have like kind of slopers and side poles and underclings every which way, and
Mm-hmm.
lots of like sport climbing areas that tend to not take trad gear. Um, but that's really just like a different part of these lava flows that cool differently, um, which makes the climbing totally different.
When I think about the idea of like the lower gorge at Smith or Trout Creek or something as being like cooling magma, I mean these places are, the walls are 100 feet or more tall, so that's like that would have been a huge field basically of cooling lava, right?
Yes, tons.
Okay,
Yeah.
yeah. The scale of that is just kind of blows my mind.
Yeah, yeah. So just a fun thing to think about the scale. We measure volcanic eruptions in cubic kilometers. So yeah, right. So think about the size of a cubic kilometer. A really good frame of reference is Mount St. Helens. It's something like a half a cubic kilometer or 1 cubic kilometer. On the other end of the spectrum, like really big eruptions. So like the Yellowstone. I hope I don't get the numbers wrong. The Yellowstone. Some of the bigger eruptions there are like hundreds of thousands of cubic kilometers. It's like tremendous volumes of volcanic rock that come out. So yeah, there's kind of a range of, what can come out in these eruptive events.
That's crazy because Helen's. I mean, I think I was like 3 years old when it happened, or something like that. But the pictures and stuff that I've seen from it seemed like pretty apocalyptic, and so for that to have been a very small relative event, that kind of gives you a sense.
I mean, there's plenty smaller ones, but that's kind of a good benchmark that everyone's familiar with. That
Mm-hmm.
there can be really little volcanic eruptions that don't amount to all that much, but there can also be ginormous ones. So yeah, no, you're totally right to think of like, hey, wait a second, this is a lot of basalt, and you're just looking at like the thickness of a crag, but then if you kind of zoom out and like where else does this layer of basalt go, and then you're like, oh, it's like way over here and way over there and way over there, and you can start to do the math of like how many cubic kilometers is that. It can add up to a ton of volume.
Yeah, that's interesting. I feel like we touched on how limestone is formed, and now we're kind of accidentally touching on would those be, I guess it's volcanic, but we're not talking about like plutonic. Should we just very briefly talk about how these huge sandstone crags are formed? Because we already covered sandstone a while ago, but I don't want to move past it without talking about its.
We could do it in a slightly more structured way, and you could keep me from taking way too long, but we could just talk about like the different types of rock. There's igneous, sedimentary, metamorphic, and then I can try to give some like quick examples of each of those things.
Yeah, I think that'd be great. Yeah.
Yeah, so we've let's talk about sedimentary rocks. So that's like limestone, sandstone, conglomerate are familiar to climbers, but it's also a whole bunch of other things that are not great for climbing. So like shale and siltstone and mudstones, and coal is a sedimentary rock. Dolomite is
Hmm.
a variety of carbonate. Um, so we kind of classify those rocks into if they're clastic. So that's like rocks that are made up of chunks of other rocks. So that's sandstone, conglomerate, and those ones we classify by their grain size. So this is kind of obvious. A conglomerate is pretty coarse. A sandstone is like sand size grains, and then as you get down into like the really fine stuff, you're in mudstones, and those tend to be really crumbly and horrible for climbing. So climbers probably won't be familiar with them. So yeah, like shale and mudstone, that's stuff you want to avoid for rock climbing. Um, So those are clastic sedimentary rocks, and then we also have like biogenic sedimentary rocks, so carbonates,
Okay.
limestones, and dolomites. So a limestone is a calcium carbonate, a dolomite is a magnesium carbonate. And there's good climbing on both of those things, on limestone and dolomite. And then we talked about chert being, within uh, limestones. It can also be a standalone rock. And I'm not aware of any climbing on purely chert crags. I think we mostly climb on chert when it's within limestone.
Yeah, I climbed some pitches in the Utah hills that had a couple bolts or something where you were climbing primarily on chert, but it wasn't other than being very discolored and very very discordant from the rest of the rock. It wasn't really anything super interesting.
Yeah. So that's sedimentary rocks. I mean, people are probably pretty familiar with those. I think geologists are pretty good at identifying sandstone versus limestone. Dolomite versus limestone is less easy to identify. It's actually even kind of tricky for geologists unless you're paying closer attention. For a climber, I would say that it doesn't really matter that much to distinguish between them. You might, if you're like looking at a geologic map, you might come across those terms, but
Yeah, I mean, when you say limestone, I think of a lot of different things, but I primarily think of like big overhanging caves, tufas, stalactites, features that look very made out of water moving down. It looks very water based. Like when you just look at it. When you say dolomite, I think a lot more like wild iris pockets. It seems, but I'm sure that there's all kinds of.
that's a really good point. So limestone and dolomite, sure, these are all marine rocks. They formed on the seafloor, and they're
Right.
they're going to be millions of years old. They're really old, and they had to be uplifted to end up where they are. But some of the features that we climb on are actually a whole lot younger. So you can kind of get stuff that's like you can have dissolution of the carbonate. Like I mentioned, that it kind of dissolves in rainwater and then it can reprecipitate. So that's when we
Mm-hmm.
talk about tufas. That's what those are. And like tufas are kind of famous for like they can be wet and there's like water streaks that they form in. And essentially what's happening is there's carbonate that's dissolving and then like reprecipitating in these water streaks. There's a few. I've been to a climbing area that was the climbing was actually on granite, but it had a bunch of limestone above it, and that would dissolve and then precipitate on top of this granite. And so there was like in places a few inches thick of carbonate limestone, but you're really the actual bedrock underneath was granite. Um, so yeah, you're kind of right. It's sorry, yeah, that it's like a marine rock, but it's also like there's kind of a modification of it in its current environment.
I mean, I'm glad I brought that up because you had said that to me before, but it only now clicked that that's why it is, because when you said it was a marine rock and it had been underwater and everything, I didn't quite understand, but now I understand the way that which it makes sense when you look at it, you can tell, the water is always running straight down the tufas and stalactites and stuff. So, but it's, again, and I think this is just why I love this stuff is like, I'm not a geologist, but it does improve my, it just makes me appreciate it to think that it took however long, millions of years for this tufa to form just for me to get here. And
Yeah, totally. Yeah, which is really cool. Some other fun points about yeah. Some other fun points about let's see, like limestones in specific, they're probably the best rock you can climb on for finding fossils. Um,
okay.
so I went to a new to me crag the other day out by Vegas, like Mount Charleston, and found all sorts of marine fossils just like at the crag, like in chunks at the bottom of the crag, on the wall while I was climbing.
Mm-hmm.
That can be really fun. So fossils to look for if people want to like try to look for some fossils at your crag. Shells are fairly easy to find. So just think of like clam shells. You might have like bivalves or you know brachiopods. Those are like different types of shelled organisms that are pretty common to find in limestones. Another one is crinoids. So those make these they're these funny creatures they're animals, but they kind of look like these underwater sea flowers. They're essentially like a filter feeder that has this stem that goes down and roots them to the ground. And often what happens is they die and they kind of like fall over and the stem disaggregates, and the stem is made of these hard kind of lifesaver looking segments. So imagine like vertebra, but they're maybe a centimeter or something across, or maybe smaller. But you can find those little segments a whole bunch in limestone. So if you're like climbing on a limestone and you see like a little circular looking, fossil, it might be a crinoid. So that's an underwater sea creature, and they're echinoderms. They have this five-fold radial symmetry. So sometimes the little lifesaver looking fossil will have a little star in the center of it, and then you're sure that you found a crinoid. So,
That's cool. And that's something that's been embedded there since it was under the ocean.
yeah, exactly.
That's cool.
You can find other stuff in sedimentary rocks. So, plant fossils, dinosaur footprints. I can't think of any climbing areas that have that, but they exist adjacent to climbing areas.
Yeah. Well, if you go spend time in Joe's Valley, not known for its limestone, but if you ever have a rest day in Joe's Valley, there is a great dinosaur museum that has lots of fossils there, and I'm sure some of them are in limestone.
I believe it. Yeah. Okay, I think that covers sedimentary rocks. We could talk about igneous rocks, which you started on. So we kind of classify igneous rocks into, are they extrusive, meaning are they volcanic? Did they erupt at the surface, or are they intrusive? They stayed underground and they never made it to the surface. So extrusive igneous rocks, those are volcanic rocks. So lava flows, things like basalt, andesite, dacite, rhyolite, we mentioned those. Those are different chemical categorizations. So it's essentially the content, the silica content of those rocks is how we classify them. But we also have other words for rocks that are kind of more based on their textures. So things like tuff. So volcanic tuff is, an explosive rock, a pyroclastic rock, an explosive igneous rock. And there's a whole system within geology of classifying different names of tuff based on the sizes of chunks in them and what the chunks are and kind of its volcanic history. So famous examples of that are Smith Rock, we mentioned, is a volcanic tuff. The Bishop Tuff, so like the Owens River Gorge and bouldering and like the Happies and the Sads, that's a volcanic tuff. And that one's cool because it's super young. It's something, I think it's like 800,000 years old. It's actually quite young. And I know that probably sounds like a lot, but in geologic time, that is quite young.
Yep.
So, and then intrusive igneous rocks. So plutonic rocks, those are like...
It's the good stuff.
Bubbles. Yeah, the good stuff. Those are like kind of, imagine like a bubble, like a big magma chamber, a big bubble of, magma underground that just doesn't erupt to the surface. It kind of stays down there and it cools, and it slowly sort of crystallizes and freezes and turns into like a big blob of igneous rock. So that's where we get rocks like granite and granodiorite. Those are plutonic rocks, like big bubbles of magma underneath. And the classification... Oh, go ahead.
How do those wind up on the surface where we can climb them? I mean, it's hard for me to understand something like El Cap being a magma pool underground.
Yes. Yeah. The very short answer is a whole bunch of time and erosion and uplift.
Okay.
Yeah.
Okay.
Yeah. So those things, they crystallize at, depths of kilometers, probably many kilometers, 10 kilometers, could be more. I mean, some rocks we climb on are lower crustal. They could be 30-kilometer depth when they formed. But over time, we have erosion happening at the surface. There's, uplift of mountain ranges that kind of brings rocks up. There's isostasy where continents kind of adjust to buoyancy in the mantle, and essentially those things that were once at great depth can be eroded up to the surface. That's a really good question. A ton of like what I do and what geologists in my field do is try to understand that. When did these rocks get to the surface? How did they get to the surface? How does that relate to plate tectonics? It's like a whole subdiscipline of geology. Yeah. Right.
Yeah, I mean, I feel like we've given the origin story for several of the different major types of rocks that we climb on. So I feel like if I didn't ask about how granite, how some of the big granite ones came to be, then I'd be remiss for sure.
Totally. So plutonic rocks and granite, we classify them based on the minerals that are in them. So the three major ingredients, quartz, and there's two different kinds of feldspars. There's a sodium-potassium feldspar a sodium calcium feldspar and a potassium feldspar. And essentially, the proportions of those are what geologists use to determine the names. So that's granite versus granodiorite versus, syenite or monzogranite
Mhm.
or monzonite. As climbers, I don't think those distinctions matter all that much. I think what matters a whole lot more is the texture of the granite, the grain sizes. So geologists have like a whole set of textural terms that we'll use to describe the grains, kind of their proportions, their shapes, how they interlock with each other. And those, I
Hmm.
think, determine the feel of a climbing area more. That
Hmm.
plus kind of like, has the granite changed in any way? Has it gotten altered? Is it crumbly or is it good granite? That kind of has to do with like its
Right.
alteration history and its erosional history.
Yeah, I think I've heard. I know. I think Bishop is monzonite and J tree maybe is monzonite, but I've also heard them referred to at times as like decomposing granite. Is that like a that doesn't seem like a technical term?
No, but it's probably accurate.
Yeah.
It's pretty accurate for climbers. I would really say like for climbers, if you're not a geologist, don't get too hung up on is it monzonite, is it granite, is it granodiorite? It doesn't
Right.
matter all that much, and those are, we define those things, but in reality, they're gradational between them.
Right. When you said that geologists have they think more about texture and they have scales for texture, it just makes me I have to ask, like, is that something that would make sense for climbers to communicate about? Well, let me give some context. Like here in Leavenworth, and I think you said you haven't climbed around here.
I have. It's been a while.
You have okay. Oh yeah, because you did go to school in Bellingham, so that makes sense. So if you came and bouldered here and you went to a few different areas, you would quickly notice like the granite in one of the canyons here, Tumwater, is much more fine grained and
Yeah.
like darker colored than the granite in Icicle Canyon, which is like chunkier and like more white and has more seems to have more variations in its color from white to gray. So like would geologists be able to look at it and be like, this is a level 5 texture, this is a level 10 texture, or like how does that work?
it's it's way more simple than you think. So if you were to look at a geologic map, and I don't know those two granites, but like let's just imagine there's two different granites in these two different canyons. The
Mm-hmm.
descriptive terms that geologists would use is calling this one's a coarse grained granite and this one's a fine grained
Okay,
granite. So that's
got it.
yeah, if you looked at a geologic map, that would be in there. We also use some terms that'll look pretty unfamiliar. So one of them that might be good for climbers to know is porphyritic. And what that means is that there is a bimodal distribution of grain sizes. So instead of the grains kind of all being the same size or gradational from small to large, there's a whole bunch of small grains and there's a whole bunch of big grains. So that's the kind of rock. So if you've ever climbed in Tuolumne on like the really knobby granite, that's a porphyritic granite where there's big crystals, these big feldspars sticking out, and then all the other crystals around them are much smaller. So the stuff that you climb on are these knobs. Those are like individual crystals that can be centimeters, pretty big, but everything else is much smaller. So porphyritic is that term.
Porphyry. So I have been to Waco tanks, which I think I've heard it's either porphyritic cyanide or cyanitic porphyry or something like that, and it's notorious for having like climbs very much like granite. It's very fine grained granite type climbing, but then it has these iron rock like black edges, and literally you'll be crimping something that's just a black thing sticking out of the rock that just feels extremely hard. So is that the porphyry aspect, you think?
Ooh, good question. I wish I had been to Waco to talk about this. But what that might be, yeah, I'll talk about it in a more general sense because this is super common in granite climbing, is that you get enclaves. So
Mm-hmm.
those are like black, usually black or dark chunks of rock. They might be small, they might be big, um, but those essentially are some other rock that's in with the granite. And
Okay.
there's different types of enclaves. They may have been what we call xenoliths.
Right.
Those are rocks that are like a chunk of something else that the granite, as the magma was like flowing through the cracks underground, it like plucked out a chunk of something else, and that kind of got brought along for the ride and then just crystallized inside. So That's like a xenolith being a foreign rock brought along. Um,
Right.
but there also can be what we call magma mingling, where you have more than one magma, and they can be different phases. So imagine like oil and water, they don't just mix easily. They're kind of different phases that want to be separate. So they might be both liquids, and then they cooled over time, and you can get these blobs of darker rock that, cooled in their own, coherent little blob, and then the granite cooled around it.
Yeah.
Um,
Yeah, we have a solid amount of that here, and we also have, there's xenoliths. There's not as many xenoliths in Leavenworth as there are in like Tahoe, Northern California, definitely, Tuolumne, places like that. But there are a lot of, random basalt holds, and I think those would classify as intrusions based on what you were saying earlier. Would that be the right word, or?
Depending on what they are. So, yeah.
There's just a mixture where you're climbing on granite, but then suddenly there's a basalt hold, or sometimes even like a whole line of basalt holds, and it makes me think like one of the things you mentioned in the outline was these like dike features that you'll get in places like Squamish. So if anybody's bouldered in Squamish and looked up at the Chief, there's a really obvious feature on the Chief that's just this line basically from bottom to top of like darker colored rock. So what is that geologically?
Yeah, that's a dike. So a dike essentially is some igneous rock that intrudes in kind of a tabular body. So oftentimes they're vertical or close to vertical, but they can be leaning. If they're horizontal, we call it a sill. But yeah, essentially it's an igneous rock that kind of like pressed its way through. And igneous rocks are, they can be under a whole bunch of pressure and trying to find the easiest way through. So they can find a little crack and kind of exploit it and just, sort of squeeze their way through under all this underground pressure and make these tabular bodies. So I know the one you're talking about in Squamish. It's if you've seen the Chief, like you can't miss it. It's super obvious. That's a basaltic dike. So that's I don't know how old that is. It's probably much younger than the granite that surrounds it, because the dike has to be younger because it cut across the thing that was already there.
Right.
So basaltic dikes are pretty common. Another kind of dike you can get are aplite. And those often are like as a pluton, a big body of granite or something is cooling. It's kind of got this last little gasp of magmatism. There's certain, parts of the magma that don't want to crystallize out. Essentially, the sodium and potassium stays in the liquid, while iron and magnesium, those will crystallize out a little sooner. And at the very end, you have kind of this sodium potassium rich fluid, and those can make dikes that are, we call them aplite dikes, and those have a really different look to them. They won't be as dark a color, and they'll be really fine grained. They're all over Squamish. They're in Yosemite. So some famous climbs like Snake Dike up Half Dome is an aplite dike, and it's got all these really cool, like juggy horn feature things on it. In Squamish, like the 5/8 start to the Grand Wall, is it Mercy Me? That's an aplite dike. I'm trying to think of some other ones. I don't know the name, but I know I did a boulder problem that was like traversing this tiny little aplite dike. So those, if you see like a lighter colored, chain of different holds going along, it might be one of those aplite dikes.
Yeah, I mean that could be super. There's a boulder problem called super dike that's like, I'm not sure if it qualifies, but yeah, there's also like occasional lines where it is still very very geometric in nature, just like very parallel lines, but it's like almost like quartz or bigger grains of granite going on in that. So is that a dike, or is that something else when that's happening?
If it's got a bunch of quartz on it, it could be a dike or a vein. If you've got really coarse minerals, we call that pegmatite. So pegmatite is a term for a rock that has very, very coarse minerals. And there is climbing on pegmatite in places. So I've never climbed there, but the Black Canyon of the Gunnison is famous for having these like pegmatite bands, and the reputation I've heard is that the climbing is often like the rock quality is worse and they're kind of run out in the pegmatites. Another place I've been is Uh, oh God, I'm blanking on the name of it. Is it the cathedral that's by Estes Park?
I think that's a place. Yeah, I've never been
Is
there,
that the place
but
with the hard climbing? So some of that is on pegmatite. I feel like I'm getting the name wrong. uh,
yeah, there is a place called maybe it's the gosh, I might have to edit this, the monastery or something, or the
well, yeah, that's
cathedral or
it.
something like that. Yeah,
The
yeah.
monastery. Yeah, yeah, yeah. We should edit this. That's embarrassing.
Grand Ole Opry, I think, is like the famous
Yes.
route. Yeah.
So those I went there once. Did not climb on those routes. But that's actually a pegmatite dike, and there's some climbing. It seemed like the easier climbs are on the pegmatite, where it has these really
Hmm.
coarse crystals. So you can find like coarse grains of quartz and feldspar, and I found this really cool tourmaline crystal, which is it's cool because it's got this like rounded triangle shape. It's like a really distinctive crystal. And then I think I walked around the corner and saw all the hard climbing, and it looked like it was on the edge of the dike. So, like,
Hmm.
right at the margin where the pegmatite had intruded whatever else was there. I forget if it's a metamorphic rock or what. Um,
Yeah, that's like that's such a classic example of like having a geologist's eye. You're kind of paying more attention to like how stuff was formed and how that's impacting the climbing that's like available. Even if you're
totally.
not literally you can't predict what a hold is going to be shaped like or something, but you can sort of tell like where the hard climbing is going to be or where the easy climbing is going to be, and or understand why those things are where they are, like that kind of stuff. It seems like.
Totally, totally. And just have a sense of like what you're climbing on and why it's different and interesting. Especially when you get on, when you get on one of these dikes or something, it's like here's a line of holds up this otherwise blank face that might be like, might be like blank for a really long ways in either direction, but here's like just this little bit
Hmm.
that has a chain of holds exactly where I need it.
Yeah.
So that could be kind of fun to like understand like why is that here? Uh,
What are like some of the places that you've climbed where you feel like those questions have been the most interesting to you? Or I mean, you don't have to have climbed there, but obviously that those would be the ones that might spring to mind the most readily.
yeah, a really good example that I just like I can't help but talk about when I go there is the climbing around Vegas.
Hmm.
Um, and the reason is so that I've climbed a lot on the sandstone and red rocks. That's like very famous climbing area that probably a lot of people can think of. And then like picture that place in your mind, and you see all these, the red sandstones, and then in the background is like the gray rock of Mount Charleston, and there's limestone sport climbing up there, but it's above the sandstone. So
Hmm.
that place is a really famous geologic example because the sandstone that's underneath is actually much younger than the limestone that's on top. Normally, you
Okay.
would have younger rocks on top of older rocks, but here you have older rocks on top of younger rocks. And that's because there's a really big, kind of famous fault in between them. It's called the Keystone Thrust Fault. And, you know, back like 60, 80 million years ago, the continent was getting squished together and everything was compressing. And so it made this fault where it pushed old rocks from deeper in the crust up onto younger rocks, and it kind of accommodated all this shortening. Um, so that's a really cool example where I think a lot of people can go to Red Rocks and like everyone notices the pretty colors and you kind of see the scenery, but,
Hmm.
but like just having an understanding of that story and like, wow, this is a really cool example. That fault moved like many tens of kilometers horizontally. It moved, I don't know exactly, but maybe up to 10 kilometers vertically. It moved a
Wow.
ton. It's like a
Yeah, that's
pretty
pretty
major
wild.
tectonic feature, and there's other. It's not just that one fault. There's actually like a whole bunch of other ones throughout those mountain ranges. So stuff like that is like having a sense of that as a geologist is like, whoa, I just get so much more enjoyment out of this.
Yeah, and if you live in Vegas and you brag about your access to climbing, just remember that those rocks moved potentially tens or hundreds of kilometers to be closer to where you are. So, yeah, don't take it for granted. I mean, I have to ask, even though it probably feels trite to a geologist, but like, what is the deal with the candy cane patterns and stripes and polka dots and shit? Because it feels completely impossible, basically, when you walk around that place.
Totally. Yeah. I mean, the colors are really stand out. It's so it essentially it's iron oxide in the sandstone that's rusting. That gives it
Hmm.
that red color. So even though the sandstone is mostly made of quartz and whatever's cementing it, it's got little bits of iron oxide. So minerals like maybe hematite, it might have small amounts of magnetite. Those are iron oxide minerals that then when like exposed to water and oxygen, they'll rust and give it that red stained color. But it kind of doesn't happen everywhere. It has to do with where the fluids were flowing and did they have oxidizing or reducing conditions as they were flowing through. And so that's kind of how you end up with like these different stripy bits, and parts of the sandstone are very red while parts of it aren't. It really has
Yeah.
to do with like a much younger history of how the fluid was flowing through it and the chemistry of that fluid.
Yeah,
Um,
that makes sense. I mean, that's one thing that I really appreciate about Red Rock is like I love granite. I love the Northwest. I'm obsessed with our rets and like the way things look here for sure. But walking around Red Rock, like if you have a small scale appreciation for what things look like if you find that inspiring or motivating, it has to be one of the coolest climbing places in the world because even like the tiny rocks on the ground sometimes will have a little like polka dot on them or something that's like so satisfying to me. And like everything from that to like the cliffs and the way that the cliffs look all the way to like you were saying, like Charleston, everything, like the big picture aesthetic of it. It's just one of the most beautiful climbing places in the world. And yeah, it's cool that it's interesting on all those different levels for sure.
can I talk about those little polka dot features? Yeah. So those you can often get like we call them concretions. So you
Okay.
can get essentially you get like a little spot, and then there's sort of like a chemical reaction that happens around some nucleating point, and you can precipitate a bunch of this iron oxide, and that can make these concretions. So not just in sandstones, but in other sedimentary rocks, sometimes you see like they might be kind of small, like little marble size things, or they can get bigger. They can be the size of your fist or bigger. Kind of these like spherical or oblate shaped iron oxide concretions. And in Vegas, there's places where those are your footholds. You might be doing a
Hmm.
move and you like see one of these things sticking out, and you put your foot on that thing, or one of them might be a handhold.
That's
Another
cool.
thing, kind of related, that you can see is where you see like these swirly, weird textures of iron oxide. Um, those are called lysogang bands. And that's again just like a iron oxide precipitating in the fluid of a rock, but it makes these really awesome, like swirly, cool colors. Um, I did a trip to the Red River Gorge a year or two ago, and there's a number of climbs that have that like very distinctively. So I
Hmm.
think like Table of Colors was that Military Wall that we went to, but that wall had like I think the colors that name probably refers to is all these like swirly iron oxide bands of we call them lysogang bands.
Cool. Yeah, it's awesome. Okay, Red Rock. What else is on your list of
Well,
interesting places?
we haven't talked about metamorphic rocks. We could do that.
Okay,
Um,
yeah, let's do it.
or, so, yeah, I got to give our three different groups of rocks: igneous, sedimentary, metamorphic. We can't forget about
Oh, okay.
metamorphic.
We're all the way back on that still. Oh my goodness. Okay, sorry. I thought we covered all
I
three.
allowed some distractions. So
No, I mean it's good to flow with it. So
we
yeah.
we probably don't have. It's probably not quite as common for climbing, but rocks that climbers might be familiar with. Quartzite is one of them. So we talked about that a bit of like a metamorphosed quartz sandstone, or you might have like really high grade metamorphic rocks. So high grade, I mean like high temperature metamorphism, high temperature and pressure. So when you take like a sedimentary rock or an igneous rock and start to bury it in the crust, you can kind of increase the temperature and the pressure, and that makes all these different chemical reactions that'll make new minerals. And different temperature pressure conditions will make new sets of minerals. And kind of a cool thing as a geologist is you can look at what minerals grew and then sort of reverse engineer what were the temperature and pressure conditions. Um,
Hmm.
so high grade metamorphic rocks would be like gneisses. So there's climbing, lots of like I can think of places in the West, like in Montana, like Gallatin Canyon, Montana, or what other examples can I think of? Like the Front
I think
Range in Colorado.
yeah, Rocky Mountain is
Yeah,
nice, isn't it?
exactly. So those have a whole bunch of gneisses. Those are like very high temperature pressure metamorphic rocks. So so kind of like a just a real quick like progression of metamorphic rocks. If you started with something that's, you know, say a sedimentary rock like a mudstone or a siltstone or something, you start to metamorphose that, you'll get things like slate would be a fairly low grade metamorphic rock, and then as you continue the metamorphism, that would turn into schist, and then gneiss, slate, and then phyllite, and then schist, and then gneiss, and they're kind of like increasing grade of metamorphism and probably also increasing quality for climbing. Low
Right.
grade metamorphic rocks are generally not that good for climbing. Um,
Yep.
but those can make really cool things. You can get like swirly metamorphic textures. You can get all sorts
Hmm.
of like new minerals that have crazy cool colors, like greens and blues and that kind of thing. So yeah, metamorphic
Yeah.
rocks.
I felt like I've climbed in Rocky a bit. It's been a really long time, and I felt like it also made like really good shapes for climbing. Like it made very very small crimps that were hard and not likely to break, and that was like that's I wouldn't say that's rare, but on rock of that steepness and to have that much of it, I don't know that I've seen other climbing, um, bouldering that steep that has that small of holds that's like bomber in the way
Yeah,
that that seemed to be to me. But it was quite a long time ago, so I don't know. People from Colorado
sure.
can let me know if I'm right about that.
Yeah, yeah. Yeah, I never bouldered there. I've climbed a bit in the Front Range, but I didn't boulder in the park at least.
Yeah,
I really would like
I mean
to.
that is. I feel like if you have a large scale appreciation for tectonic plates moving things tens or hundreds of kilometers, you probably would be attracted to the bigger features. But like my initial forays to trying to understand um, not even how rocks formed, but I just literally wanted to find boulders to climb on. It wasn't nearly as high minded as understanding how things got there. And like my intuition was always to try to find the features that the boulders may have come off of, or to try to find the angles of repose where the boulders would wind up. And so I did a lot of like hiking river canyons and like looking on Google Maps at river canyons and looking for talus fields and hiking to those things. I mean, do you do like development? Do you do first ascents? Is that something you've applied this knowledge to much?
I don't, but I kind of can't help myself from looking, of like where climbing could be and
Mm-hmm.
what the geology is. So I definitely spend time, even though I'm not a developer, I definitely spend time looking at geologic maps and things like LiDAR to figure out like where cool climbing might be and like what kind of rock it's on.
Mm-hmm.
Um, so those, if you want
Should
to
we?
have a couple tools we could talk about. So I have a couple
Cool.
ideas of like how could geology help climbers or like help you, one, understand the rock that you're climbing on, and then two, like find new rocks to climb on. So I could go into those.
Let's do it. Yeah,
So
let's do it.
let's talk about, okay. So one tool of how can you like understand the rocks that you're climbing on. If you're going out and you're going for a day of climbing, you want to figure out what you're on. Maybe you know that it's sandstone, but like what kind of sandstone? How old is the sandstone? What's the relationship of that sandstone to other rocks? The thing to look at would be a geologic map. So across the country, we have very good coverage of geologic mapping, um, at like both detailed scales and kind of zoomed out scales. So a website to go to look at this is the National Geologic Map Database, so NGMDB. And if you just Google that, it'll take you, it's a USGS website, it'll take you to a web page, and they have this thing called the map viewer. And that viewer, if you click on that, it'll bring up a map of the country, and then it'll overlay geologic maps on top of that. And so you can scroll around and find your local climbing area. Um, there's like a little transparency slider bar where you can kind of adjust the transparency of the geologic maps. Find your climbing spot and then figure out on a geologic map, what is that rock type. So a geologic map, I can kind of talk about how to read them because it's not necessarily intuitive. What it's going to be is like a topographic map, so a map of like the mountains and topography and contour lines that people are probably accustomed to looking at. And then on top of that, it's going to be colored with a bunch of different colors that signify the rock type. And then there's lines in between the different colors that show the interfaces. We call them contacts between rocks. And if it's a thick line, it's a fault. If it's a thin line, it's like a sedimentary contact or an igneous contact. So if you're trying to understand your rock type, like locate your crag on the map and then click on that map, and it'll bring up a different page. There's kind of like a way to inspect the map on this viewer, and that map will have a legend that's got a legend of the different rock types and the color codes of all these different rock types. So if you're looking at a map and you see like your crag is in an orange color on the map and it says KGD, that's going to be an abbreviation for the map unit. And the big letter, the K, that's going to be the time period. So K is actually Cretaceous. We have all these different ways of kind of shorthanding different parts of geologic time. And then the GD might be a granodiorite. Or it may have a name. It might be like a Dakota sandstone or something.
Right.
So yeah, if you find your where you were located on the geologic map, and then go to that legend, and it'll tell you what unit that is. And then these maps, they'll have a description of the rock. Sometimes it's right on the map itself. Sometimes there's like a report that goes alongside the map. And it'll have a section called a description of map units. And written into that, some are more detailed than others, kind of depending on the map and the purpose of why it was made. But it'll have like a kind of technical description of what that rock is made of, how old it is. And then the report, not always, but often will have a description of the geologic history of the area, of like what are the important geologic features and different events that shaped the landscape. So that's kind of in a nutshell, like a pretty quick way to like just gain a basic understanding of like what's the rock that you're climbing on. It'll tell you in that map like how old it is. It'll tell you if there's distinctive fossils, the different gradations of rock types within a single map unit. There's a ton of information in there. So.
Even just the number of things going on the map, I think, tells you something, because when I look at the NGMDB for Washington, it has like a ton of different colors on it on all the maps, like very varied, lots of things happening. And when I go down and look at it in Oregon, like it's a little bit, there's still a lot, but it's a little bit more like one note, I think, than Washington, which does sort of tell you something about the type of climbing that you're going to find there for sure.
Yes. Yeah. And that's really like geologic provinces. So, like Western Washington, the geologic province, you have all these accreted terrains. So essentially things that got like smashed onto the edge of the continent and all pushed together. And so there's all sorts of different chunks of very different things. Other places you might go, you might just have like flat sedimentary layers, and the geology is a whole lot more simple. And so the geologic map will look a whole lot less complicated. So that can be a fun thing. I mean, the maps with all the colors, they can look pretty artsy. Like they're fun to look at even for non-geologists. People love to take our maps and like, put them up as wall art, or, look at maps of national parks and things. And it's really cool to look at. So, yeah.
It's neat. There's a lot to be gained there. When we did our initial interview, you also showed me, I believe, a LiDAR tool that could theoretically be used to find, variance in the elevation or whatever that might indicate like a crag.
Yep. Yeah, totally. So this would be a tool that people could use to find cliffs or find boulders, and it's going to be really handy in places where it's forested. So folks have probably heard of LiDAR. It's in like self-driving cars. Essentially what LiDAR is like a laser scanner, and it's sending out pulses of lasers and kind of timing how long it takes for them to come back. And then you can figure out, what you're looking at and how far away things are. So geologists use airborne LiDAR. We put a LiDAR scanner in an airplane and fly over and scan the land surface. But the really cool thing is you can write an algorithm that takes only the points that made it through the canopy of the forest and to the ground and back up. And you write this algorithm, and essentially you can remove all the tree cover and just see what's underneath. So it really starts to expose these features that if you just looked at Google Earth or aerial imagery, you're just going to see the tops of the trees. But when you look in the LiDAR that's kind of deleted the trees, you can see all the features that are underneath. So you might see boulders, you might see cliffs that are hidden in the forest. It's a really awesome tool for that. It's super cool for geologic mapping and the geology we do. Just go cruise around climbing unrelated and look at cool geologic features that you can see in the LiDAR. You'll see all sorts of glacial features and different landforms. You can see like road cuts and development, and anything that's like modified the landscape stands out really well. So a good place if you want to look at LiDAR, you can do that for free with just a browser. So the USGS has 3DEP, the 3D elevation program. So 3DEP. If you just punch that into Google, and that'll take you to a website. If you look for like the 3DEP LiDAR viewer, they have a few different viewers that you can use that will have LiDAR data already processed that you can kind of just cruise around and explore in your viewer. If you're like the more advanced user, there's other websites that download it and load it into mapping software, but probably most people don't need to bother with that. There's, well, I was just gonna say there's pretty good coverage of the 48 states. It's not complete coverage, but it's going that way. There's still some holes and gaps, but the amount of LiDAR coverage across the U.S. has gotten way better over the last few years. So there may be places that didn't have LiDAR just a couple years ago that now do, and that could be really handy for finding cliffs.
For sure. What's the I'm not even sure what the right word would be, but like how fine of a scope is this that it's working with? Like how tight of a scope is it?
Yeah, totally. So the LiDAR that we use is often 1 meter. So the pixels would be a meter. It
Gotcha.
might be half meter. They're usually 1 meter or better. That's kind of like the quality standard of LiDAR, and that's pretty good. Like, you know, the super fine details of a boulder or a cliff might not come out, but like you'll see that there's a boulder there. You should be warned. The algorithm that they use to strip out the trees, they also strip out buildings. So like houses and stuff or buildings that stand out, the algorithm will remove those, and you'll just kind of see like, you know, what it would look if it was flush with the surrounding landscape. Occasionally that will remove boulders. There's places where I've looked where there's like some big standalone boulder, and it actually, you know, it's a real natural feature, but it got kind of stripped out of the bare earth LiDAR. So be warned that that might happen.
It's I guess it's like multi-directional in some sense, but it's not going to like get down in a cave and like, you know, see that there's like some
Right.
feature down there, right?
Yeah, if it couldn't be flown, you know, if you can't see it by flying over it with a plane, you're not going to be able to see what's underneath. So
Right.
you'd have to have. We geologists do use terrestrial lidar scanners for all sorts of studies of like, you know, landslides or glaciers or something. You can mount a lidar scanner just on the ground and scan stuff, but the lidar that we use for mapping that's like widely available is airborne.
Right. Yeah, the rumor mill here that I've heard, or the rumor that I've heard here is that one of the newer bigger crags in Washington was like found by people using LiDAR and then not even hiking to it, just like flying a drone to it in order to like check it before they like bothered hiking all the way to it. So I do kind of feel like it's sort of the future for that kind of thing if you have a little bit of time on your hands and a little bit of
Yeah.
expendable
I mean,
income.
yeah, like pre-LiDAR, even with LiDAR, probably a lot of us spend time like looking at Google Earth and just checking stuff out. I mean, I do that all the time.
Yep.
It's really cool. And that's still a really good way to go because anything that can be seen with satellite imagery, you can catch with Google Earth. LiDAR is going to
Yeah.
be really handy in forested areas where like you can't see what's underneath. Yeah.
That's the big thing that makes me curious. I mean, not that I have free time coming out my ears, but you know, back when I had a more of a desk job, day job, like anytime I was in a meeting that my immediate participation was not required, I was usually surfing Google Earth, because it requires like just a low enough amount of brain power to do it that I could still pay attention to whatever was happening. You know,
Yeah.
yeah, I found some things to go look at doing that. I have a whole lot of
Nice.
pins that I've never made it to. So
That's awesome. And if you want to do
yeah,
that professionally, just, you know, get a geology degree and become a mapping geologist. And you won't necessarily get to look at the places that you're interested in for climbing, but I
hmm
do spend, you know, my hours in my day job looking at LiDAR and Google Earth and trying to map things
that's
out.
pretty cool.
It's pretty
Yeah.
fun. Uh,
Are there other things about being a geologist that you feel give you a leg up on rock climbing?
ooh, I don't know. Um, Not that I could think of. I think,
Yeah, it's
I
really
think
just like
like
the appreciation of
enjoyment.
nature.
Yeah,
Yeah.
yeah. I think, it's actually something that's actually really cool. I thought of one is like the sense of geologic time and how that relates to changes in the landscape. So, you know, things that happen in geology happen over a very long time. And, like we're thinking in timescales of thousands, millions, billions of years. These just like tremendous, incomprehensible timelines.
Yeah.
But the processes that are happening are kind of happening constantly. So people like to say like geologic time includes now. So meaning
Mm-hmm.
like, rockfall and just like all the processes of geology, earthquakes, those happen within our lifetimes or can happen within our lifetimes. And it's, the perspective of geology, it's the perspective of this deep time has kind of given me like, okay, you see some rockfall, now multiply that times millions and millions of years and imagine how the landscape is evolving over time. And that can be
Yeah.
pretty fun because you can really witness, you see some rockfall at a crag or something, some part of a climb fell down or something, and you're like, yeah, I can imagine that over time that would accumulate into, evolution of this mountain range.
Yeah.
So that's really cool.
It is cool. I mean, it's a little harrowing also because there are aspects of geologic time that I find disconcerting. Hundreds of cubic kilometers of stuff coming out of a volcano. I don't like that idea. But
Totally.
you know, having been in Squamish over the last few years, and there's been quite a few like large scale rock falls there. It's like it closes some of the climbing. Sometimes it affects the climbing. Like there's a really famous climb that used to be like a jump start, and then you were doing this highball lip traverse, and after one of the slides, like a giant slab just slid. It didn't hit the boulder, but it just slid right in so that the boulder's like no longer a highball. You just climb it with this,
Whoa.
kind of apron underneath you. Things like that are really interesting to me. And of course, and obviously those landslides deposited like lots of other boulders that had new problems on them and stuff. And it's bizarre to see those things happen and think that, that's exactly what happened for all the other boulders that are there at the base of the Chief. It's
Yes.
just that most of them landed there thousands of years ago or whatever, and had lots of time to sit there before we arrived. So I find that stuff fascinating to think about, for sure.
I have a related story if you just want a fun story.
Yeah.
I climbed the Rainbow Wall over the weekend in Vegas, like this,
Oh, cool.
pretty famous, well-known multi-pitch that's been done like thousands and thousands of times. We were climbing it, and as we're going up, like my friend who was leading was like finishing this pitch, and it was like kind of all this choss on this little ledge, and it was like, whoa, why is there all this loose choss here? And he belayed me up, and the next pitch, which the topo marks as having this like kind of scary loose hollow flake, had completely changed. On the start of this pitch, that big loose flake had fallen off.
Wow.
Yeah, and it's a thing that like people had commented on mountain projects of like, oh, watch out for this loose flake. It feels kind of scary. And we got up there and it was gone. And there was no chalk on it. There was dirt behind it. It was like, whoa, I think we are the first ones. So like, yeah, did it totally, I mean, the good news is that it went. It didn't change the route.
Oh, yeah, I was going to say the good news is it seems like nobody was climbing on it when, when it went away.
Exactly. But it's kind of wild to be on a trade route that's like been done so many times, and then like here we are, and I think there was no chalk on it, so I'm pretty sure we were the first ones to encounter it, and it definitely changed like those 10 feet. Of this famous
Didn't
route.
a good chunk of the main route up Half Dome like fall off not that long ago?
Yeah, because didn't it used to go free more easily, and now it doesn't on regular route. I've never climbed it or anything, but that's my understanding.
Yeah, I think it changed. I'm not same. I'm not enough of a big wall climber to really know one way or the other. I think one of the most interesting takeaways for me from talking to you is just, I already knew this intuitively, but for some reason hearing a geologist say that like, the hardness of the rock doesn't really have anything to do with whether it's going to climb like it's chossy or not. I think that's really important to remember. And it's to me, it's related to the flake because not that long ago, a few weeks ago, I was out at a sport crag and climbing on this, whatever random route that had been developed not that long ago. But the crag is like pretty bomber. Because they did a really good job of like pulling everything off. But the rock there is like spectacularly hard, really high quality granite crag. But there was like a hold at the bottom of one of these routes that I was like, basically saying like, hey, I think I'm gonna like go stand on this, and the guy was like, oh yeah, totally. I like reefed on that with the pry bar, like it's super solid. And I was like, really? It just doesn't seem like it, and I'm not sure why I was doubtful, but he had the pry bar and brought it over, and we like pulled on it, and it just popped right off. And it was, to me, I was immediately like, oh no, like, do I need to like discount? I don't know why I felt shifty about that one thing, but I was like, do I need to like discount all the other solid holds at this crag? And, you saying like the rock can be hard and also still be, I'm not probably using the right terms, but jointed or whatever in some way that makes it, weak on like a bigger scale than just what you're grabbing onto. I think that's really valuable for me to think about.
Totally. Yeah. And that actually really controls a lot of, what the climbing feel of an area is. Yeah. Jointing is a good term. So joints, essentially, they're expansion fractures. Other kinds of fractures would be like faults. Those are shear fractures. But yeah, just, a rock can be really hard, but if it's very fractured, it's going to be choss.
Yeah, totally.
And it can change, like, the feel of a climbing area. Does it have a whole bunch of fractures, and like, what's the relationship between those? Do they make 90-degree angles, or do they make 120-degree angles? How does that change the holds? Are they good side pulls, or are they slopey side pulls, that kind of thing? Or
yeah,
are they good cracks or bad cracks?
I said earlier that like I'm really into arrettes, and I like aesthetically I find arrettes and squeeze problems and stuff very, very pleasing to look at, and they're fun to climb too. But this is making me realize that like something that I really like about them is that there's like an immortality to like an arrette or a lip traverse or like a squeeze boulder that you just can't get with even with really bomber rock, and crimps. It's like someday if enough people climb that thing, it's gonna like erode and change. But like, there's a certainty to like arrettes and compression climbing and stuff that I find really interesting, I guess, or inspiring.
Yeah.
On that note, I want to ask a couple of these patron questions, because we did get 2 questions for the geology expert. So, cool. Did you have a chance to look at these, by the way?
I did, yeah, and I actually wrote down what I was going to say. So.
Okay, sweet.
That'll make it better.
Okay, so I think what I was just saying connects to this, so I'll read Sam's question. He says, does prolonged climbing have a negative effect on outdoor climbing holds? If so, how can we slow down this process and properly care for each different type of rock to ensure that the generations that follow us enjoy as fresh of a rock as possible, even on the classics? I know for me, classic is almost like a bad word. Like when I go to a new climbing area, like there's certain climbs that stick out in my mind as people are like, this is like 5 stars. And then I went and climbed it and I was like, wow, that probably was 5 stars in 1992, but now it's like I'm just climbing on what's left of it, basically. So, yeah, how do you think we can do a better job of taking care of that? Does geology tell us anything there?
Yeah, I mean, I think I'm just going to answer this question as a climber, and like, it's kind of obvious when you go to certain climbs that stuff gets polished, stuff gets rounded out. It's probably most prevalent on like limestone and sandstone. Limestone can get really polished. It does kind of hold a polish, which is nice in the sense that it's not just like completely breaking off. You lose the hold entirely. Sandstone, you get holds will like, what was once a crisp edge then rounds out into something that's not a very good crimp anymore. But it even happens on things like granite. I'm thinking of, some of the climbs in the Smoke Bluffs and Squamish, like they are very noticeably polished. I'm sure that's true on the boulder problems. I probably don't know them as well, but yeah, I mean, I don't think my geologic experience gives us anything, actionable that we can do to prevent this. But I think just sort of thinking about it rationally, like, clean your shoes on a climb. If you have any like grit on the bottom of your shoes, that's like coarse sandpaper. That's just kind of like, it's essentially erosion. It's just not a natural erosion. That's, people climbing on it causing the erosion. That kind of thing. I do think there's probably a degree of like, don't just like climb on stuff way too much. If it is that status that it might get rounded out and polished, like, don't top rope something to death maybe, but at the same time, I don't want to gatekeep people. Like everyone should be able to get on the classics.
Yeah, it's tough. I mean, the reason, you said the Smoke Bluffs are so polished and like they're so easy to get to, and there's numerous like very well-known turbo locals who go out there and climb 50 pitches a day, a few days a week or whatever, and they're just repeating the same, 10A over and over, like free soloing them like over and over and over, because it's a really easy place to go do that. And you don't want to take that away from them, but no doubt that contributes at a certain point. Like it's a non-renewable resource, right? Even if we do take super good care of it. And the fact that you don't have that as a geologist, you don't think there's anything special about it, or, you're not saying like, oh, this type of rock is like accepted from that, and this one's safe. You're like, all of them are something that we need to pay attention to and like treasure. I think that is just as valuable, honestly.
Yeah. I think another one is wet rock. This is, I mean, a very commonly talked about thing is like, don't climb on soft sandstone when it's wet. And I mean, that's a real thing. So I did kind of dig into the literature, and there's definitely literature about loss of strength of sandstones when they're saturated. But it's not just sandstones, actually. It's porous rocks. So, something like a granite has very low porosity. It doesn't change, it changes very little when it's saturated. But, something like a porous tuff could, or some limestones are sandy limestones, and they have a bunch of pore space. So I think, I think everyone recognizes, like, don't climb on a soft sandstone, but harder sandstones are okay. But then when it comes to like limestone or other rocks, we're like, don't worry about it. I think maybe it's like, a better rule would be like, don't climb on soft rock that's prone to breaking when it's wet. Don't climb on that stuff when it's wet.
Yeah. I mean, it's just better safe than sorry. Like I have been witness to at least one mega classic boulder problem breaking because people were climbing on it like in a fog. Basically, I wouldn't even say that it was raining, but it was humid enough, and the rock was potentially porous enough that a hold broke. And like the feeling of shame that you weren't the one who was like, hey, maybe we should stop, like maybe nobody should be climbing on this right now. It's a very strong feeling, and avoiding that feeling is a good enough reason for me like to not want to do something like that again. Nobody wants to be that guy who does that.
When a classic breaks, like the community is gonna want a finger point, whether that's helpful or not. I don't want to be in that position.
Yeah, I mean, I'm philosophically, I'm more of the opinion that it's like it's more important to do the right thing than it really matters, like whether you're doing it for the right reasons or not, as far as like the good of the people, the good of the community, right? So if you just want to do the right thing for selfish reasons because you don't want to be the guy who breaks the hold, like that's good enough. It doesn't have to be altruistic. Yeah, I have seen like people say that granite doesn't matter as much for not climbing on it when it's wet, but here in Leavenworth we've had like numerous classics break in the last handful of years. I don't think that they break nearly at the same rate that things do in places like Red Rock, but things definitely still break, and it's obviously still a bummer when they do, and a lot of the time it is happening the day after a rain or an afternoon when it was raining in the morning or whatever. So don't think that granite is like a special outlier. I don't think.
And I think there probably is a pattern that, I don't have any data on this, but just after storm events or after big like temperature swings, if it was super cold and then it becomes really hot, there are going to be fluctuations and things expand and contract a little bit, and maybe it got like ice wedged or cooling and drying of a storm. Those things, like maybe just kind of watch out, partly so you don't break classics, and partly so you're not like impacted by rockfall and have some injury because of it. So.
I mean, the freeze thaw, like I developed a crag outside of Portland, sport climbing crag for a few seasons, and like every spring, this is a like not columnar basalt, but like overhanging fractured basalt crag, kind of like Deep Creek or places like that. And every spring you'd come back and like noticeably there would be new rocks on the ground underneath the crag, and there would be like obvious scars up in the, not necessarily on the roots, but just visible from the ground. And it was sort of like, oh yeah, like these things are changing pretty fast, like you have to sort of be heads up. But that crag was really sketchy. So
all of my closest calls with rockfall have been basalt, usually single pitch basalt. It can be sketchy. And part of that actually does circle back to the geology. So I was talking about the different parts of a lava flow. Oftentimes the worst rock is at the very top or the very bottom. So some
Mm,
crags you have the stuff that's good for climbing, near the ground or in the middle or something, and then some crags you like, the climb ends, the cliff keeps going, but the rock just gets way worse, and it's like the
right.
parts of the lava flow that as the lava's flowing, those things cool on the top, and then they kind of crunch themselves up as it moves along, and that can kind of lead
Yes.
to bad rock, and that stuff just like natural rockfall can be scary.
For sure. And the crag that I was talking about, you have that, and then you also have like where the steep part ends. As soon as it pulls over into a head wall, and actually a little bit before that, like there's so much more vegetation up there from what's on top of the
Mm-hmm.
crag, and so it just obviously that's growing roots down into the rock and like doing all kinds of other things. It just like very quickly gets sketchy if you go too high. So the roots all just end at a logical
Yeah,
at a
yeah,
logical height.
yeah,
Yeah.
yeah.
Okay. Nico asks, we kind of talked about this a little bit, but I'm just curious if you have any other thoughts. He says, advice for developers, such as things about CHOS people don't know. Also curious if there's a difference in mechanical fatigue in certain types of rocks, like cyclic loading at lower loads, eventually leading to cracks and fractures. So those are kind of two different questions. Um, let's take the first part first. Do you have any other advice for putting up first ascents that we haven't talked about?
Yeah, yeah. So we kind of talked about those tools of understanding where you can find rocks and what the rocks are, but about
Mm-hmm.
CHOS. So having a geology background, it doesn't give me a huge leg up in predicting where good rock is, but I definitely can predict where bad rock is. So there's all sorts of things in geology that can, like, either they're bad rocks to start with, like you would just never climb on them in the first place, or they're ways to like weaken rock over time. So bad rocks to
Right.
start with would be like shale and siltstone and mudstone, some of these things I've mentioned, like just really crumbly stuff. I mean, things you probably will walk up to them and decide like you don't want to climb that. But if you're looking at a geologic map trying to figure out where to go, you saw some cliff in the distance and you're trying to figure out like, is that worth walking to? If you look at a geologic map and it says that it's shale, like probably not. That's probably going to be
Mm-hmm.
some pretty bad rock. Other maybe less obvious things, so ways that you can like take good rock and make it bad geologically. So alteration, like where you have chemical reactions, usually with fluid flow, that can like really reduce the quality of rock. So I said that a granite is made up of quartz and two feldspars as the main ingredients, plus some other minerals. If you take those feldspars and run fluids through there, they'll alter and they'll turn into clay minerals and get really grungy and crumbly, and that would be like bad granite. So if you're looking at a geologic map, and it says something about alteration, or sometimes they'll have like a little pattern on the map, and it's like, oh, this is a zone of alteration. That's almost certainly going to be pretty bad rock for climbing. Other things like that, like
Gotcha.
brecciation. So rocks can get brecciated would be like something that's like crunched up. So stuff like fault breccia. If there's a big fault zone with a whole bunch of faults running through, having like these slivers of rock kind of squishing past each other crunches things up, and it can kind of like pulverize the rock, and that makes it way worse for climbing. So
Got it.
if you see breccia on a geologic map, especially like a tectonic breccia as opposed to a sedimentary breccia, those are probably pretty bad rocks. Um, I guess another thing I'd mention, like at the outcrop, if you're or at the cliff, if you're like putting in bolts or like knocking off choss or something, it might be helpful to understand the fabric of the rock. So by fabric, I mean does it have any layering? Does it have any kind of like direction to it? So in a sedimentary rock, this might be like the sedimentary layering, the layers in which everything was laid down. In a metamorphic rock or an igneous rock, it might be be like a tectonic fabric, like a metamorphic fabric where the rock got squished and all the minerals aligned, or like maybe there's a flow fabric of an igneous rock. But those will change how a rock breaks. So geologists get pretty good, and probably people developing cliffs as well get pretty good at like figuring out how rocks will break. We're always like collecting samples, and sometimes it's really hard to
Mm-hmm.
break open these rocks with sledgehammers. you, but as a geologist, when you have a rock with a fabric, you get pretty good at like, hey, I'm gonna set this rock down, but then like turn it on edge and hit it this particular way, and I'll predict that it's going to break along this layering. So just for
That's
like
cool.
a developer, you might be able to, with some experience, kind of gain that skill of, which directions are stronger and weaker in a rock, and maybe that influences like how you clean something or how you put in your bolts, that kind of thing.
For sure. Yeah, I mean, that makes me want to mention, like, when I first developed roots, I haven't developed that many roots, but I've put up a few here and there. And I was basically just shown how to do it by another developer. I didn't get it. I just got mentorship. I didn't have any resources or anything. But now, if you were interested in developing roots, there's, I think it's a YouTube channel, although I don't know the channel very well, but there's a website associated with it called How Not To. And there's a guide on there called the Bolting Bible, I think it's called. And I read the whole thing in a day or two, and if I go bolt more roots, I'm definitely going to reread chunks of it. But there's whole pages on, like, how to bolt different types of rock and how to know, like, where to put the bolt in the rock, exactly because of what you're talking about, like how to sort of predict where it's going to be good. And I was just told, like, take the hammer, tap the rock, and if it sounds hollow, it's bad. Basically, pick the least hollow sounding place that you want to put the bolt, pretty much. So yeah, the Bolting Bible might be something worth checking out if people are interested in developing roots.
Something I'd add to that is be aware that the surface might be different than what's behind the surface. So we were talking about like limestones and how you get dissolution and reprecipitation of stuff. Think of like tufas. They're just kind of on that surface, but if you're putting in a bolt, it might go through that into much softer rock. So I'm sure developers are pretty tuned into, if the drilling becomes very soft after drilling through a hard crust, like that's maybe not a reliable bolt. But just be aware of that kind of thing, and maybe look for like the fresh surfaces that probably don't have a crust on them, where the consistency of the rock is going to change.
Yeah, that feels like something you would need to really understand if you were bolting sandstone, especially because it seems like with sandstone, I'm holding a great hold, and then like the next thing is to sand.
Yeah, that definitely can happen.
Well, Skyler, I appreciate your expertise. Are there any other things that you feel like we haven't covered that you want to bring up?
There was a part 2 of that question, the cyclic fatigue in different rocks. Well, so the bummer is that I'm not the person to answer that. I think.
Oh, okay.
It's a really interesting question, and I imagine there probably is some difference in different rock types, but that's really a question for like an engineer, maybe like a geotechnical engineer, somebody that works on bolts and is more familiar with like testing them. I think it's a super interesting question, and I unfortunately can't answer it.
Okay. Well, I appreciate you taking a crack at it anyway. Anything else?
I don't think so.
I feel like we touched on a lot of good stuff.
Yeah.
Well, I often close out the podcast by asking people sandstone or granite, really just to satisfy my own intuition that granite is the best. So I have to ask you, what's your favorite type of rock to climb on?
Probably limestone, but sandstone or granite, I would pick sandstone. The reason is there's so much variety in sandstone.
Yeah.
There's so and you can get such cool features. Like you can have amazing like splitter cracks trad climbing, or you can have like jug hauls. You can have soft sandstone and hard sandstone. There's a ton of variety.
Well, interestingly, what I'm learning from this is that I actually do really like sandstone. It's just all the sandstone I like is like the metamorphic stuff that's like more quartzite. So I feel like that's a takeaway from the podcast for me is, it's the class, not the type of rock, but the class that it's in seems to be the thing that matters.
Yeah, essentially the history of it and how well lithified is it, how well cemented is it. Yeah, that's a cool thing is there's so much variety. I mean, there's so much sandstone out there that nobody climbs on because it's just total garbage. So, the same thing can be said for granite, but granite tends to just in general be better, but I think I'm going with sandstone because of the variety.
Nice. Well, I love it, man. Thanks so much for coming on and sharing your geeky love of rocks. I really appreciate it.
Yeah, you got it. That was really fun.
Cool. Thank you.
Awesome. You're welcome.